Welcome to this explainer. Today, we're tackling a topic that's practically a rite of passage for every new programmer. Honestly, it sounds a whole lot scarier than it actually is. We're talking about Python classes. If you've ever heard developers toss around terms like object-oriented programming and felt a wave of pure intimidation, or if you've just wondered what on earth a class actually does, you are exactly in the right place. Our goal today is super simple. We're going to completely demystify this concept for absolute beginners. We're tossing out the confusing textbook jargon and replacing it with clear logical steps to get you building.
Okay, let's dive into this. We're going to start with a really fundamental question. How do we actually group data and actions together in Python? To understand why we even need classes, let's imagine the messy alternative. Picture yourself writing an application to manage a high school. You've got hundreds of students. For every single one, you need to store data, their name, their age, their grades, and you need actions, like having a student introduce themselves or enroll in a class. Without a real system, you'd be typing out hundreds of isolated variables, like student1_name, student1_age, student2_name, and so on. It's an absolute nightmare. The code becomes impossible to read and incredibly prone to errors. We desperately need a clean, structured way to tie that specific data and those specific actions together into one neat package.
Section 1. The Blueprint of Python.
So, what is a class? Well, a class is simply a blueprint for creating objects. It groups related data and actions together. To solve that messy organization problem we just talked about, think of an architect designing a house. They don't just walk into an empty field and start blindly throwing bricks together, right? They draw up a meticulous blueprint first. A class in Python is exactly that. It's the architectural plan. Now, I really want to emphasize an absolutely crucial insight here. The class itself takes up zero memory in your application. It isn't the actual physical house you can walk into. It's just the abstract paper drawing that dictates exactly how to build it. But once you have that blueprint drafted, you can use it to build as many houses, or in our case, as many objects as you want, and they will all share that exact same, perfectly organized structure.
And this brilliantly illustrates the two main components every Python blueprint boils down to. On one side, we have attributes. Think of attributes as the nouns or adjectives of your blueprint. These are the static data points, the variables, that define an object. For a person, attributes would be things like their name, their age, or their eye color. On the flip side, we have methods. If attributes are the nouns, methods are the verbs. These are the dynamic actions or functions, the actual things our object can do, like walking, talking, or introducing yourself. A Python class just wraps these two things, the descriptive data and the active methods, into a single, beautifully logical unit.
Section 2. Building the student class.
All right, let's look at a basic example and translate this abstract idea into real working Python code. We start out simply by typing class student. This announces to Python that we're officially drafting a new blueprint. Then we write def__init self name age. We'll decode the exact mechanics of that line in just a second, but for right now, just know this is where we define those nouns, the attributes for our blueprint. We're basically telling Python, hey, every single time you build a student from this blueprint, make absolutely sure they are given a name and an age. Those lines underneath, self.name equals name and self.age equals age, are just us taking that information and securely saving it into the object's personal storage space.
Let's move on and see how this builds. Directly below our static data, we give our student a verb, an action. We define a method by writing def_introduce_self, followed by a print statement that says my name is, grabs the name, and I am, and grabs the age. We've just given our student blueprint the ability to do something. Notice how it uses that self keyword again. That word acts like a bridge. It allows the dynamic action to seamlessly reach back into the object's personal storage, grabbing its specific name and age to complete the introduction. With that, our blueprint is completely drafted.
So, stepping back, here's the complete life cycle of creating an object. Step 1, we define the blueprint, which is the class student code we just wrote. Step 2, we actually construct a real object based on that blueprint. When we write s1 equals student jai 18, we're doing what developers call instantiation. That's just a fancy word for the exact magical moment we go from a paper drawing to a tangible, real-world object taking up memory. We've created a student, named him Jai, set his age to 18, and stored him in a variable called s1. Finally, step 3, we tell our object to do its thing. We call s1.introduce, and the output, Python prints, my name is Jai, and I am 18 years old. Boom, we brought our student to life.
Section 3. Decoding key concepts.
Now, what's really interesting about this slide is how it demystifies all that tricky jargon. If you were looking at those underscores earlier and feeling a bit overwhelmed, take a deep breath. It's totally normal. Let's decode these key concepts. The word class defines the blueprint. That underscore init term, that's known as the constructor. It runs automatically the exact moment an object is created to construct its initial state. It gathers the lumber and bricks, so to speak. Then there's self. It just refers to the current object. When Jai introduces himself, self literally means Jai. Finally, attributes are just variables inside a class, and methods are just functions inside a class. See? Not magic at all. Just incredibly useful tools with very specific jobs.
Section 4. Your Day 1 practice.
The absolute best way to cement this into your memory is to see it applied again. So let's look at a Day 1 practice example. Here we write class car, followed by our underscore init constructor, setting up a brand attribute, and then a show underscore brand method that prints out that brand. So the crucial point is, this car blueprint perfectly mirrors the exact same attribute and method logic as our student example. This is the major aha moment in object-oriented programming. Once you know the structure for a student, you inherently know the structure for a car, a bank account, or a video game enemy. The underlying architecture remains completely identical.
And to wrap up our practice, we create the object. We write C1 equals car, Toyota, bringing our car to life. Then we tell it to act by calling c1.showBrand, which cleanly outputs brand, Toyota. By mastering just these few foundational lines of code, you've successfully crossed a major threshold today. This is usually enough for a Day 1 introduction to classes. You've graduated from writing basic, messy scripts to architecting proper, object-oriented software.
Which leads us to a really exciting question for you. What blueprint will you build next? Now that you have the architectural tools to group your data and actions together cleanly, think about the apps you use every single day. When you open Spotify, Netflix, or your banking app, realize that underneath all those slick interfaces, it's really just a vast collection of these exact blueprints. Users, songs, movies, accounts, all interacting with each other. The possibilities literally are endless. You've got the foundation now, so open up your code editor, start experimenting with your own Python classes, and watch your ideas come